friends, kwenye kipindi hichi naenda kuendelea na topic yetu ya coordination, na leo tuna discuss rules of synapse. Kipindi kilichopita tulikuwa na discuss synaptic transmission na tuliona how it can occur step by step. In this session we are going to discuss about the rules of synapse. Synapse inaweza kufanya kazi mbalimbali tu ambazo kwenye vitabu kama biological science, rules of synapse na functions ni vitu tofauti. Kwanza kuna kitu tunakita excitatory synapse, alafu kuna kitu tunakita spatial and temporal summation. Excitatory synapses, spatial and temporal summation. Kwanza tunaposema excitatory synapse maana yake nini? Kuna baadhi ya synapse ambazo nerve impulse ikifika inafanya depolarization kwenye postsynaptic membrane. Wakati kuna baadhi ya synapse ambazo nerve impulse ikifika inafanya hyperpolarization, yani inafanya inside of the membrane kuwa more negative, thus decreasing the probability of generating action potential. Kwa baadhi ya synapse they are excitatory synapse, manake zina excite the postsynaptic neuron, while some of them they are inhibitory synapse, that means they inhibit the postsynaptic neuron, zinafanya postsynaptic neuron asitengeneze nerve impulse. Now at excitatory synapse, ion specific channels open up and allow sodium ions to enter and the potassium ions to leave down their respective concentration gradients. This leads to a depolarization in the postsynaptic membrane. The depolarizing response is known as excitatory postsynaptic potential. Hii depolarization bado haijawa action potential, ni potential ambayo ni ndogo, yani haijafika kwenye action potential. Kwa hiyo ili excitatory postsynaptic potential iweze kuwa action potential lazima ziungane nyingi. Yani kifupi ni kwamba hii impulse ni kama vile it is weak, it can't cause the excitation of the action potential if only one synapse ikiwa imetoa neurotransmitter. Unaona, the impulses from many synapses they must summate, zinatakiwa zifanye summation, zi add up, zijumlishwe, yani impulse moja na impulse mwingine wajumlishwe, wafanye summation ndio wa create action potential katika postsynaptic membrane. Tulichokuwa na discuss kwenye kipindi kilichopita it was a simple mechanism, lakini actually what happens ni kwamba any impulse haiwezi kutengenezwa kutoka kwenye synapse moja, kutoka kwenye synaptic knob moja. So not one presynaptic neuron ina release pale ndio inasababisha action potential ku develop. No, it must be whether two or more presynaptic neurons or the frequency of that stimuli must be very high. So the depolarizing response is known as the excitatory postsynaptic potential, and the size of this potential is usually small but longer lasting than that of action potential. So the excitatory postsynaptic potential size yake ni ndogo lakini ni longer lasting, inakaa muda mrefu kuliko action potential. Now the size of excitatory postsynaptic potentials fluctuates in steps, suggesting that a transmitter substance is released in packets rather than individual molecules. Fluctuates in steps, manake ikiwa released one packet pap, hiyo inakuwa ni step, unaona, ambayo excitatory postsynaptic potential inakuwa inatengenezwa. Walijuaje? Ni kwa sababu walifanya experiment, wakafanya conditions ambazo neuron huwa inaishi na wakaona release of neurotransmitter na kwaje. So a single excitatory postsynaptic potential is normally unable to produce sufficient depolarization. Is normally. Here what we are talking of is just the normal conditions. Normal conditions. So a single excitatory postsynaptic potential is normally unable to produce a sufficient depolarization to reach the threshold required to propagate an action potential in the postsynaptic neuron. Normally, a single excitatory postsynaptic neuron is not enough. However, it does increase the chances of further excitatory postsynaptic potential, generating an action potential, an effect called facilitation. So the formation of one excitatory postsynaptic potential facilitates the coming neurotransmitter released at that synapse to develop an action potential. Manake tulivyo-release neurotransmitter za neuron moja zinakuwa zinaongeza chance, zina facilitate. Ku facilitate, it is just like influencing, kuongeza chance. It increases the chance of further excitatory postsynaptic potential to generate action potential. Effect hiyo inaitwa facilitation. Yani one excitatory postsynaptic potential increases the chance of the coming the next excitatory postsynaptic potential to generate the nerve impulse. Hiyo effect inaitwa facilitation. Lakini why does the excitatory postsynaptic potential increases the chance of the coming excitatory postsynaptic potential to develop an action potential? Kwa nini? Kwa nini excitatory postsynaptic potential moja isababishe excitatory postsynaptic potential anayefuata generate action potential? That's because they undergo what we call summation. Zina add up. So nachokisema ni kwamba the depolarizing effect of several excitatory postsynaptic potential, it is additive. Very important for you to remember. It is additive, a phenomenon known as summation. I just bold this word additive so that you can understand. It is additive, a phenomenon known as summation. Now what is summation? Summation ni kule kuadd excitatory postsynaptic potential moja na nyingine. Unaona? The two or more excitatory postsynaptic potential arising simultaneously at different regions on the same neuron, usually from different neurons, may produce sufficient depolarization to start an action potential in a postsynaptic neuron. So the two or more excitatory postsynaptic potential, they can be generated from different neurons or from the same neuron. So hizi mazingira zote zinaweza kutokea, either they are generated from different neurons au from the same neuron. Lakini kitu ambacho tunatakiwa kujua hapa ni kwamba zikiwa developed from different neurons, hii inaitwa spatial summation. Wakati zikiwa developed au zikiwa zimeoriginate from the same neuron, inaitwa temporal summation. Kwa hiyo you can just observe this phenomena kwamba two or more excitatory postsynaptic potential arising simultaneously at different regions on the same neuron, usually from different neurons, may produce sufficient depolarization to start an action potential in a postsynaptic neuron. This is spatial summation from different neurons. So these two, they arise from different neurons, and then they call the development of the action potential at the postsynaptic membrane. This is the postsynaptic membrane. It is known as the spatial summation. Unaona, this is spatial summation related in space. Figure hii hapa, hii figure hapa, hii diagram hapa itakiwa iwe translocated. Yeah, itakiwa translocated tu hapo. Kwa hiyo that is spatial summation. But from there, pia sometimes the rapid repeated release of transmitter substance from several synaptic vesicles by the same synaptic knob as the result of intense stimulus produces individual excitatory postsynaptic potential, which are so close together that they summate and give rise to the action potential in the postsynaptic neuron. This is temporal summation. So temporal summation inatokea kama hivi. Tunakuwa tuna two successive impulse katika one neuron. This is spatial summation ambayo tunakuwa tuna two presynaptic neurons zinakuwa zinapeleka impulse kwa pamoja. Unaona, temporal pamoja na spatial summation. Therefore, impulses can be set up in a single postsynaptic neuron as the result of either weak stimulation by several presynaptic neuron or repeated stimulation by one presynaptic neuron. Hizo ndo spatial pamoja na temporal summation. But as I have told you that kwamba hizo synapses hizo kuna discuss hapo juu zinaitwa excitatory synapse. Zinaitwa kama excitatory synapse. Some of the synapses they are not excitatory but they are inhibitory synapses. Inhibitory synapses. Kwa hiyo baadhi ya synapses zenyewe ni inhibitory synapse. Baadhi ya synapse ni inhibitory, nyingine ni excitatory. So the excitatory synapse zinapelekea development of action potential, while the inhibitory inhibitory synapse hazipelekea development of action potential. Inhibitory synapses, unaona, at inhibitory synapses the release of transmitter substances increase the permeability of postsynaptic membrane by opening up ion specific channel to chloride and potassium ions. So has open sodium zina open chloride and potassium channel. As chloride ions rush in and potassium ions rush out down the air concentration gradient, they produce a hyperpolarization of the membrane known as inhibitory postsynaptic potential. Inhibitory postsynaptic potential. In other words, they make the inside of the neuron more negative down to as low as negative 90 millivolt. This makes the neuron less likely to trigger an action potential. It is inhibitory synapse. Zina inhibit the development of action potential in the postsynaptic neuron. Transmitter substances themselves are neither inherently excitatory nor inhibitory. Japo zipo chache, for example, GABA is always used the inhibitory neurotransmitter katika brain, katika central nervous system. GABA is always inhibitory neurotransmitter. Lakini kuna baadhi ya transmitter nyingine kama acetylcholine, it can act as excitatory or it can act as inhibitory depending on the site where it is functioning, the nature of the synapse ambayo inakuwa inafanya kazi. So the transmitter substance themselves, they are neither inherently excitatory nor inhibitory. For example, acetylcholine has an excitatory effect at most neuromuscular junctions and synapses, but it has an inhibitory effect on neuromuscular junctions in cardiac muscle and the gut muscle. In cardiac muscle and the gut muscle, the neurotransmitter acetylcholine inakuwa ina inhibitory action. These opposite effects are determined by events occurring at postsynaptic membrane. The molecular properties of the receptor sites determines which ions enter the postsynaptic cell, which is in turn determined by the nature of the change in the postsynaptic potential as described above. Kwa hiyo molecular properties za hizi inhibitory synapse zinakuwa zina namna ambayo zita allow the entry of choline and potassium ions rather than allowing the entry of sodium ions. Then finally after that we have the neuromuscular junction. Neuromuscular junction is the specialized form of synapse found between the motor neuron and the skeletal muscle fiber. Remember, the motor neuron carries impulse from the central nervous system to the effector, which might be muscles or glands. So the specific junction between the muscles and the motor neuron is what we call the neuromuscular junction. So each neuron muscle fiber has the specialized region, the motor end plate. Each neuron muscle fiber has specialized region called the motor end plate, where the axon of the motor neuron divides and forms fine branches ending in synaptic knobs. Kwa hiyo katika hii neuromuscular junction tunakuwa tuna motor end plate. The branches lack a myelin sheath. The branches lack a myelin sheath, and the neuromuscular junctions include both the motor end plate and the synaptic knob. Motor end plate ndo hii hapa unaona. Hii ni motor end plate inayotengenezwa katika muscle fiber. Hizi hapa ni synaptic knob ambazo zinatengenezwa pale. Huku chini tunakuwa tuna muscle ambayo inakuwa na microfibril. Katika hizo microfibril kuna nyingine kuna mambo ya A line, Z line. For your level it's not much important for you to understand. Unaona? So this membrane is called, the fine branches run in shallow through run in shallow trough on the cell surface membrane of muscle fiber. Unaona, this membrane is called sarcolemma. Sarcolemma. Hii membrane inaitwa sarcolemma. Cell surface membrane of muscle fiber inaitwa sarcolemma, and has many deep folds in trough, is shown in this figure. Have many deep folds in trough. On stimulation, the synaptic knob release acetylcholine. On stimulation, the synaptic knob release acetylcholine by the same mechanism as previously described. Changes in the structure of receptor sites on the folds of sarcolemma, the postsynaptic membrane, increases the permeability of the sarcolemma to sodium and potassium ions, and a local depolarization known as end plate potential. Naona changes za depolarization hapo zinapelekea kudevelop kitu kinaitwa end plate potential. End plate potential is produced. This is sufficient to lead an action potential passing along sarcolemma down into the muscle fiber through the transverse tubules and T system. Actually, you can't understand about the T system in this part because it's not for your level. This action potential results in muscle fiber contraction as described katika kipengele cha 18.47 ya biological science. So for your level, you are not required to know the mechanism of muscle fiber contraction. How does this happen? Finally, this is the diagram of neuromuscular junction. I was forced to discuss about the neuromuscular junction because I found some of the exams, they ask you maybe to label this diagram, or they can give you any questions related to this diagram. Finally, we have the functions of synapse. We have 3 rules of synapse, but we have about 7 functions of synapse. So since synapse have the effect of slowing down nerve impulse by about 0.5 millisecond per synapse, hiyo ni kama disadvantage, but it can be assumed that the advantages overweight this disadvantage. Advantages or functions of synapse, they are summarized here below. Ziko about 7. First is unidirectionality. How it ensures the transfer of nerve impulse in one direction. Unidirectionality. The release of transmitter substance at presynaptic membrane and the location of receptor sites on the postsynaptic membrane ensure that nerve impulse can pass only in one direction along a given pathway. This gives precise to the nervous system, allowing nerve impulse to reach particular destination. So this is what we call the unidirectionality. The transfer, it ensures the transfer of nerve impulse in only one direction. Second is amplification. Sufficient acetylcholine is released at neuromuscular junction by each nerve impulse to excite the postsynaptic membrane to produce a response in muscle fiber. Unaona? So sometimes synapse zina uwezo wa kuamplify, zinaongeza. Yani acetylcholine iliyoingia ni kidogo, nerve impulse inayokuwa generated ni kubwa. Thus, nerve impulse arriving at neuromuscular junction, however, they are weak. Are adequate to produce response from effector, thereby increasing the sensitivity of the system. So even if they are weak, but they can generate the action potential. Why they can generate the action potential? The reason behind is because of the amplification. Synapse ina uwezo kuamplify the impulse na kuifanya iwe more stronger. Third is adaptation and fatigue. Kilichopo ni kwamba unapokuwa kwenye mazingira fulani, kwa mfano labda uko kwenye mazingira ambayo mashine inaunguruma mwanzoni, ukiwa umekaa pale utakuta unasikia sana ile, lakini baadaye na utakuta kusikia ile mashine inaunguruma inakuwa ni kama vile unaishi hakuna mashine. The same place, unaweza kaingia ndani ya chumba, in the room there is the watch, then ukasikia ule mshale unaenda ta 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 ta, lakini baadaye ukuta ni kama vile mle ndani kama hamna saa yoyote. What is the reason? The reason is because of fatigue. Yani ile constant stimulation ya ule mshale wa saa ile constant stimulation inasababisha neurotransmitter ziwe released kutoka kwenye presynaptic membrane mpaka baadaye ziishe. Zikishaisha, you will not hear again ule mlio wa saa. Hasa ile namna ya neurotransmitter kuisha ndo tunaita fatigue. Lakini that is an adaptation. Kwa nini? Kwa sababu ina allow kama hiyo stimulus ni intense isiende kuharibu effector organ. That is an adaptation. Kwa it is important also. The amount of transmitter substance released by synapse steadily falls off in response to constant stimulation until the supply of transmitter substance is exhausted and the synapse is described as fatigued. Further passage of information along this pathway is not possible until after a period of recovery. The significance of fatigue is that it prevents damage to an effector through overstimulation. Adaptation also occurs at levels of receptor, and this is described later. Tuta discuss tena baadaye kuhusu adaptation and fatigue. Adaptation ni nini? Lakini function ya nne ni integration, convergence and spatial summation. Integration, convergence and spatial summation. Integration ni uwezo wa neuron kuungana na kuintegrate the information, kuunganisha zile information kutoka neuron zinaunganishwa kwenda kwenye information moja. A postsynaptic neuron may receive impulses from a large number of excitatory or inhibitory presynaptic neuron. This is known as convergence. Postsynaptic neuron ana receive impulse kutoka kwenye many presynaptic neuron, inaitwa convergence. Kwa convergence ni arrangement ambayo if we have the presynaptic neurons, let's say we have presynaptic neuron 1, presynaptic neuron 2, presynaptic neuron 3, then we have other presynaptic neurons, presynaptic neuron 4, a presynaptic neuron 5. Unaona, if we have this presynaptic neuron, then you have only one postsynaptic neuron. Hii phenomenon tunaita ni convergence. And the postsynaptic neuron is able to summate the stimuli from all presynaptic neuron. Hii postsynaptic neuron inakuwa na uwezo wa kusummate, kujumlisha impulse inatoka kwa huyu zinajumlishwa zote, is able to summate. A simple example is shown in figure hiyo hapo katika BS figure 17.12, lakini kwangu mimi utaikuta hii figure huko mbele na nitakwambia hapa ndo tuionyesha integration na convergence ndo hii hapa. This spatial summation enables the synapse to act as the center of integration. It acted the center of integration. It acted the center of integration of that stimuli from a variety of sources and the production of coordinated response. The center of integration. Number 5 is facilitation. This occurs at some synapse. Baadhi ya synapse zinafanya facilitation. This occurs at some synapse and involves each stimulus leaving the synapse more responsive to the next stimulus. Unaona kwamba kila stimulus inayoondoka kwenye synapse anakuwa more responsive, yani anakuwa na uwezo mkubwa wa kutengeneza response. The sensitivity of the synapse had therefore been increased. The sensitivity of the synapse has therefore been increased, and subsequent weaker stimuli may cause a response. Weaker stimuli may cause a response. Kwa unakuta stimuli yenyewe iko weak lakini bado inasababisha response. Facilitation is not temporal summation. In that it is chemically controlled response of postsynaptic membrane and not an electrical summation of postsynaptic membrane potentials. Kwa hii sio kwamba inakuwa ni summation ya membrane potential, bali ni chemically controlled, inakuwa controlled na postsynaptic membrane yenyewe. Chemically controlled, not due to the effect of the summation of the impulses. Number 6 is discrimination and temporal summation. Discrimination ni ile namna nimekwambia kwamba zile stimulus ambazo sio za muhimu sana they can be just ignored by the nervous system. So temporal summation at synapse enables weak background stimuli to be filtered out before they reach the brain. Weak background stimulus to be filtered out before they reach the brain. Ndio maana mtu anaweza akawa sehemu anapiga kelele lakini yeye yuko pale anaenda kusoma, anaenda kufanya nini. The reason behind is because of the temporal summation ambayo inafutilia mbali, ina filter out the weak stimulus, weak background stimulus. Unaona? For example, receptors in the skin, the eyes and the ears receive constant stimuli from the environment which have little immediate importance for the nervous system, such as background noise. Kwa zile pale zinakuwa ignored, nervous system ina ignore zile background noise. Only changes in the intensity of stimuli are significant to the nervous system. These increase the frequency of stimuli and pass across the synapse to cause the response. So discrimination ni kule kufanya zile impulse zilizoko weak zisifike kwenye brain. Lakini number 7 is inhibition. Kama tulivyosema kuna inhibitory synapse. The transmission of information across the synapse and neuromuscular junction may be prevented at the postsynaptic membrane by activity of certain neurotransmitter or drug. As described in the next section, presynaptic inhibition is also possible. It occurs at synaptic nodes that are in close contact with the synaptic knob. Actually, next section tukitoka hapa kwenye BS ilikuwa ni ina discuss drugs and neurotransmitter. So kwa sisi hatuta discuss kuhusu drugs kwa sababu sio, it's out of our scope. Tuta discuss tu kuhusu neurotransmitters, nazo hatuta discuss kama vile kwenye BS tulivyo discuss. Ukitaka kuelewa zaidi hichi kipengele nenda kwenye BS. Actually hichi kipengele kiko out of scope of our syllabus, sikuweza kukiingiza kuhusu drugs and neurotransmitter. Kinamfaa labda mtu wa first year anayesoma medicine, lakini for form 6 form 5 kiukweli nitakuwa nawaonea nikiweka na hivyo. So tunachokisema ni kwamba it occurs at synaptic nodes that are in close contact with synaptic knob from inhibitory synapses. So stimulation of these inhibitory synapses reduces the number of synaptic vesicles released by the inhibited synaptic knob. This arrangement enables a given nerve terminal to produce a variable response depending on the activity of its excitatory and inhibitory synapses. Synapses allow control by a range of neurotransmitter in the brain. They allow control by a range of neurotransmitter in the brain. This chemical control increase the complexity and subtlety of control of behavior. Kwa hiyo katika kipindi kijacho tuta discuss categories of neurotransmitter before we are moving to sensory receptors. Categories of neurotransmitter before we are moving to sensory receptors. Thank you and let me wish you nice studies.